What's defined as material science, and what does a material scientist study?
Mhm. To me, um, anything that is tangible and comes to the use of humanity as material, tangible, right? So this table is material. The, the microphone in front of me, the diaphragm that's vibrating is material. The armature that's holding it in place is material. Um, there's a huge debate that goes on between metallurgy, materials, and what should be taught, what shouldn't be taught, what should be subservient to the other. In my opinion, metals, non-metals, all are part of materials. So I have no issues in putting iron and steel under materials.
Okay.
They're all materials. Some happen to have different characteristics from the others, but materials is a broader aspect of all tangible substances that we use in common that is in common use today.
Mm-hmm.
What we study is essentially how to make the right material for the right use.
Mm-hmm.
Right. I'll take an example. Airplanes were made with aluminium.
Mm-hmm.
Yeah, light metal. You wouldn't think of making airplanes with steel.
Mm-hmm.
That's not the right material. Its density is high. It corrodes. You make it out of stainless steel. It's too expensive. High density. You make it out of aluminium, which doesn't corrode, is lighter weight. You can rivet pieces of aluminium into place. It's quite solid, right? But as you go to larger airplane bodies, as you go to lighter bodies for less fuel consumption, you look for different materials for that use purpose. So aluminium gives away to carbon fiber, and maybe a carbon fiber combination with titanium, right? Because carbon fiber doesn't go well with aluminium. There's a huge corrosion issue, right? So external issues like fuel saving, lightweighting, dictate use of materials, choice of materials. Therefore, as the need to reduce fuel use, and therefore go to lighter weights in planes became stronger and stronger, the search was on for an alternative to aluminium. So all the new large body planes that you see are a combination of titanium and carbon fiber, right? Mm-hmm. So all these are in material science. How do you find a material that's right for the use case that is being thought about?
Mm-hmm.
Today, you're talking about quantum, right? Quantum computing. Now, you're going to smaller and smaller sizes, right? In the nanometer scale, even. If you cross the 22 nanometer size, you can no longer use silicon as a gate. You have to go and find another material. So it becomes a material problem. So whether it's a plain body or whether it's a gate in a semiconductor, these are all materials problems. Some electronic properties, some deal with mechanical properties, some deal with chemical properties, some magnetic properties in motors, for example, right? So underpinning everything that we do in day-to-day life is materials. And I would put all of these together under material science. And I think study of a broader aspect of material science is very important, because the student comes out knowing, being given a holistic picture of materials, right? Not just iron and steel, or not just aluminium, not just plastics or silicon, right? Gets a holistic picture, and therefore, right from formative years, has the mindset of choice of materials, right? Whether it's aluminium or steel, whether it's silicon or something else, or graphene, or whatever. That materials are a matter of choice for a particular use. That is what material science education should be.